Sai Ram, fellow soldiers. My name is Darshan Governor and welcome back to Byte Fusion. So we are now officially on day 6 as it seems to be for our programming lessons on Java. Okay, cool. So let's get straight into it. Okay guys, so if you remember last time when we left off, I think we might have done methods. We did methods and we spoke about loops as well. I'm not too sure what that last video was, but if you want to check that video out, at the end of this video, there will be a screen where there will be like the different videos you can select from, and I'll take you to the previous video. But nonetheless, let's begin lesson 7. So guys, in today's lesson, we're actually going to learn about arrays in Java. So guys, this is basically what an array is. So in Java, you have bits of information that you can store as variables. We know that. But what if you wanted to store collections of information, like say we want a list of vehicles or we want a list of people? Then in Java, there's something very useful that you can use to store those elements, and that's called an array. Right. So in Java, unlike a primitive data type, basically allows a storage location for memory. It allows you to allocate memory to the variable, but for an array, you don't actually allocate memory. Instead, you assign a storage location to that array, or rather it's called a reference storage location. Okay, so exactly how do you define an array? Right. So as you can see here, we have element type, array reference variable. Okay, so this is basically how you store an array. So you have element type, so that can be like an integer, a string, any sort of type that you want to declare it as. Then we have an array reference variable. So that's the variable that's going to be taken, that's going to basically be in place of the name of the array that we're going to use. Next, we use the assignment operator. We have to use the new operator. Just like we declare an object in an array, we also have to use the new operator. And then after that, we specify our element type once more, and we open up our square brackets, and inside the square brackets, we can insert our array size. And then of course, we have to end it off in a semicolon. Cool, so let's actually define an array. So I'm going to call this array int, and I'm going to call it scores, right? I'm going to say scores, int array, int scores. Right, so now I've declared my array, but I haven't initialized it to a specific storage capacity, right? I haven't initialized the capacity, so let's initialize the capacity. So I'm going to say scores is equal to, and we'll say int, right? Remember to put new in the beginning, int, and let's give it 7 spaces or 7 allocations. Right. So basically, I just created an array called scores, and what scores doing? Scores is storing basically like your scores. So what are your scores? The scores I'm referring to are the scores that you get in your academic record. So like after high school, you get a certain amount of scores, you get a percentage. For instance, in math, you might get a percentage, say 87, and then so on for all the other subjects. So I've decided to call that scores, and that's my array that I've declared. Now, this is one way to declare an array. You can basically initialize it, you can declare it, and then you can initialize it. Or you can declare and initialize it all at once. So let me show you how to do that. So to declare and initialize it all at once, all we do is we put it on one single line. Scores is equal to new int, right? And then we can put the 7 in there. And we can actually comment this out because we don't need it. Comment it out. Oops, my bad. Comment it out. There we are. So that's new scores. Right. So we've actually declared an array called scores. All right, guys. So it's very important that when you go through arrays, that you need to understand how arrays are initialized. So just now we actually initialized an integer array, right? But you can also initialize other arrays as well, as I've mentioned. But you'll notice that whenever you initialize an array, you create a capacity for it, it actually assigns default values to the different positions, the different slots within the array get the default values. For instance, if we had to use an integer array, then the default value in some location in the array would be 0. If it's a char, it would be underscore would be \u000. That's basically an empty space. If it's a boolean, it'll be default to false, and if it's a string, it'll be null. So I've actually created these arrays, numbers, characters, triggers, and strings, and I've printed it out. So let's see what that looks like. Okay, so as you can see, we have, as default, we have integers as 0, we have characters as spaces, false as booleans, and nulls as strings. Right. So guys, those are basically I would say the four most commonly used type of arrays that you would use in Java. Right guys, so now that we know a bit about what an array is and how to declare it, exactly how do you use an array? Like what can you do with an array? So one thing I've decided to show you is how you can loop through an array and you can print out data. You can basically assign values to an array, and you can also print out an array. So you can input and output of an array. So what I've done is I've created this random. So this is a random generator. It's called Rn. We have string scores, which is another array. And we have this for loop here. So what is this for loop doing? The for loop is looping from I equal to 0. Now remember, whenever we start at an index, we always start at index 0. So in an array, say we have 7 elements in our array, right? So we start from index 0 in our array and we go up to element number 6. Not element number 6 exactly, but index 6, element number 7, right? So that's basically what this for loop is doing. And we can see here we said I is less than scores.length. Now the reason why, you'll notice that in an array, unlike a string object, an array we don't have to put these curly brackets, right? I mean not curly brackets, these just regular brackets. For an array you don't have to do that. You can just put .length. Okay, cool. So you can see as we loop through this, we are basically assigning a random number between 0 and 100 to scores I. So scores 0 will get a random number, scores index 2 will get a random number, and then so on. And we're basically saying, now this is something else you can do in Java. So if you want to transfer transfer the contents from one array to another, if you want to transfer contents from one array to another, then you can simply just copy those elements to another array. For instance, I've actually created a string array called string scores. So now I don't want the scores to be as integers. I want them to be as strings, right? So I created string scores, and what I'm basically saying here is string dot value of scores I. So we've already generated a random value for scores I, but now we transferring that element in scores I to a new location in string scores, right? And to do that, we need to convert an integer to a string. And what we've done to do that is we've used this method called value of, which basically converts an integer to a string. And then after that, I've printed out the array string.join our string scores, and I've basically printed that to the console. So the string class actually has a method called join, where you can join different strings together. So I've decided to join these strings with a comma. So I put a comma and a space, and you'll see exactly what I'm talking about when I run the program. Right, so I'm going to run it. I'm going to execute this. Let's see what happens. Right, so we have 96, 52, 25, 33, 78, 77, 57. Right, so that's basically all the elements that we randomly generated. And that's what we've printed out to the console because we wanted to print out string scores, so we've got this whole string here. And you'll notice with join, the method join, you can't use an integer to join, right? You basically want to concatenate everything with this, but you don't want the end to concatenate with it. So that's what makes a join so effective, is that you can join all these strings together in between, but you don't add in extra bits of information like this comma at the end or at the beginning, because you don't want that there, you want it in the center. So that's why join is very useful in Java. Okay, cool. So guys, that's how you can loop through an array in Java, and that's how you can assign an array, and that's how you can basically change values in an array. So let's talk about the different data types that you can use in Java. Okay guys, so I talked about typecasting and integers and strings, but I never really showed you how to convert between integers and strings, how to convert to a float, how to do type conversions. I've never really showed you that. All I've done is I've showed you how to basically typecast, how to cast to another data type, but I haven't showed you how to exactly convert between those data types. So that's exactly what I'm going to show you. Right, so you can see I've declared this int xl1 is equal to 12, right? So it's an integer, and I basically said print out the type of name, the type of object this is, what type of class is this. Okay, so we know this is an integer data type, right? And then I've said string y is equal to integer.toString. So what does that do basically? We want to convert an integer to a string. So to start off, we use the keyword integer because that's the class we're converting from, and then we want to convert it to a string class, and we've done .toString, and that's the method. And then there's actually a way to convert to a string. You must use toString, but to convert from a string to any other data type, we use pass. We basically pass the data type. So for this third value, we're doing double.pass double y, which basically converts it back to a double, not an integer. This time we're converting it to a double. You can do pass integer as well. You don't have to do pass double, but because we can declare it as a double, we're using pass double. And then you can do integer.parseInt. You can see I've done it here. Boolean.toString. You can even convert a boolean to a string. So this false will actually be converted to a string. And then we've got a string here called true, and we've converted this true to a string equal to true. We're printing out that class. We know it's a string. And now we're going to want to convert that string to a boolean. So we say .parseBoolean. So true will become a boolean. We can even do this with character, guys. We can even convert with characters, right? Like you have the character C1 is equal to capital letter A. We want the class name. We want the data type. We're saying character.toString, so we're converting that A to a string. And we can even convert it back to, we can convert a string, a single character in a string to a character by doing .char@. So you'll notice that with characters, you have to do .char@. So unlike .pass double or .toString, for a character to convert a string to a character, we don't use pass. We do .char@, and we want the location of our string, and we say at char position 0. Now, if you have bigger strings, like say you have the word Java, right, and you want you want the A in Java, then you would say .char@, and you would say position index 1. So 0 is J and 1 is A. So that's how you can get the character from a string. Okay, guys, so let's see if this actually works. Right, I'm running this, and you can see, so it does say this is an integer, y is a string, z is a double, l is an integer, m is a string, n is a string, we've got o is a boolean, we've got c1 which is a character, p which is a string, and c2 which is a character. Okay, good. So that's basically how you can do type conversions in Java. Okay, everyone. So just like before, we were talking about how to use a for loop in Java. Well, there's actually something that you can use that's much simpler than a for loop. In fact, it's so simple that you only need the elements. You don't even need to look at the index. You just need the elements. And that, ladies and gentlemen, is called a for each loop. So how does a for each loop work? Well, firstly, you have to use the keyword for, and then you open up your brackets. You have your element type. So our element type is an integer. We're going to use the keyword int. You specify your elements. You can call it anything. We've decided to call our elements x, colon, add a colon, and then your array reference variable. So the array reference variable we're referring to is called scores. So we want to print out each and every element in scores, right? Which is basically what the system.out is going to do. So if we run this, right, you should see we get 46, 89, 90, 84, 43, 56, 84. And this is verified because at the top, you'll see we have 46, 89, 90, 84, 43, 56, 84, which is basically what's been printed out in this other for loop on the top here. I'm basically system.out the print line, right? Okay, guys, so that's how a for each loop works in Java. So now that we actually have our scores, right, which is basically looking for the academic record of a student, well, there's actually a way to pass arrays, right, through methods. So basically, how does that work? So just like you can pass a variable to a method, you can also pass an array to a method. But there's a big difference. Now, if you remember in my previous video, I've mentioned that we pass by value when we pass a variable. However, when we use an array, we pass by reference. So what does that mean? The reference of that array is passed. We don't copy the array elements. We pass the entire reference. So that means that whatever is going to be manipulated in the method is going to be manipulated in the main method as well. So that method is going to manipulate the entire array altogether. So this array here, string scores, is actually being manipulated in grades, in the method called grades, right? It's being manipulated. Yeah, so it's actually changing. So this string R over here is the same as string string scores. It's exactly the same. They're both referring to the same array. It's a reference. And in the same way that we can pass a reference to a method, pass a reference of an array to a method, we can also return a reference of an array. So when we work with arrays, we work with references. Okay, cool. So basically I created this method. It's called grades. And what does it do? It looks at each individual score and it assigns a grade to it. So if the grade is greater than or equal to 80%, that's an A. Greater than or equal to 70, it's a B, and so on. So let's run this and see what happens. Okay, so as you can see, instead of getting the values 89, 57, 3, 73, 63, all of that, we actually get our letters, right? Our grades. So we've got an A, a D, an F, B, C, B, and A. Very unrealistic for a student, but that's basically what we got. Right, so I want to actually show you that you can also return an array. So I'm going to uncomment this section over here. I'm going to uncomment that, and I'm going to say public static. And we're going to say int. Right, because we're returning an array, we have to declare it int, and we have to open up our square brackets. Right, we're returning R, but it's giving us an error. Sorry, my bad. We have to return a string. So we use a capital string. Right, and we go back to the top. And then we can just uncomment this line here. And these lines can be commented again. Okay, right, so we can save this and we run it. Okay, as you can see, we get a new set of results. And this student performed very poorly, but for some reason they got 3 A's and 4 F's. I don't know how that's possible, but that's what we got. So you can see it actually works as well when we return a method. Okay guys, so let's move on to the next section. Okay everyone, so now that we've actually talked about arrays and how we can use them, the different data types, and we've spoken about looping through arrays and how arrays can be passed to methods. Well, you can actually search through arrays, right? Like say you want to search for some sort of element in an array, then there are 2 ways in which you can search. So the first way is called a linear search. Let me just comment this out. It's called a linear search. So this is how a linear search actually works. So I've actually put in these elements. So we've got 34, 23. So they're basically random integers, right? And I've said my key is equal to 98. So we are actually looking for the element 98 in this list. So I've created a method called linear search, which takes the list and the key. You'll see it's here. Sorry, not there. There we are, linear search. So linear search basically, it loops from the beginning of the array to the end of the array, and if it finds the key, it returns the key value, otherwise it returns -1. So let's see what happens if it returns like that. So if it returns -1, we'll print no match found. If it actually prints something that's not -1, then we know it's found the elements in the array. So if we actually run this, you'll see it says match found. That's because key 98 actually exists in the list. Let's try another value. Let's try something that's not in the list, maybe 101. No match found. Okay, cool. So that's basically how a linear search works. Okay, so another type of search you can use is called a binary search, and I'm going to explain how that works right now. Right guys, so a binary search is a special type of search, and you'll notice that in programming, whenever we talk about different loops and we speak about searching, we speak about sorting, we speak about different type of iterations and all of that, people will usually mention, not people, I rather say programmers will talk about time complexity. And this is where time complexity becomes very effective, because binary search actually has a lower time complexity, which means its time complexity is better than a linear search because it takes less time to search for an element. Now, I won't go too much into time complexity, but as time goes on and we learn more about programming in Java, I will eventually touch on the topic time complexity, and we'll be doing some really advanced searches and stuff, and you'll get to really understand what complexity is all about. But nevertheless, let's go through binary search. Okay, so binary search takes a list and it takes a key. So one thing you need to notice about binary search is that the elements in the list need to be sorted before they can be searched. And you'll find out why right now. Okay, so you can see we have binary search here, and we have int list and int key. So how does this work? Basically, what it does is we look at the lowest index and we look at the highest index. So we assign our low to our lowest index and our high to our highest index. And then we put it into this while loop. When we say while high is greater than or equal to low, this is what's going to happen. Find the midpoint, right? Say, for instance, you have 10 elements. Then we know low plus high, which is 0 plus 9 divided by 2, right? So we got 0 plus 9 divided by 2, which gives us 4.5. But since it's an integer, we're going to truncate and we're going to keep it as 4. So 4 is our midpoint. Now it says if our key element, the integer, the element that we are searching for, is less than the midpoint, right? The midpoint value, then we're going to set high to mid minus 1. And our list will basically go, so if mid was 4, for instance, then now we would have high as 3. High would be 3 if our value was less than the element at position 4, right? If the key is equal to the midpoint elements, then we return the midpoint and we've successfully found our value. However, if it's higher than the midpoint, then we set our low to mid plus 1. And this type of loop continues until we basically find our midpoint. And if it doesn't, I've said here return minus low minus 1. Now you've noticed this is quite different to returning negative 1, because we could return negative 1, right? And if we return negative 1, then that basically means that we haven't found the element. But we want to show something additional, and that's what this return minus low minus 1 is doing. So what it's basically doing is that it's showing the position where you can insert the element because it's not in the list, right? So if we were to find this element in the list now, it would be inserted in this position. Okay, so let's actually run this and see how it works, because of course talking about this is one thing, but running it and actually visualizing it is another thing. So let's actually try to do that. Right, so I've said key is equal to 27. You can see 27 is not on the list. Right, so if I save this and if I run this, execute it, you'll say no match found, but this element can be inserted at position 3, right? Because we know that midpoint is basically minus 2. The last midpoint we ended off on was minus 2, which was like here, right? Minus 2. And we say minus 1, so we're bringing it up to 3. And because we've done math.absolutes, so we found the absolute value, right? Math.abs, which gets the absolute value, then we're returning the actual position it can be inserted in. But notice that it hasn't found the element. So what happens if I actually put in an element that does exist? So let's try 70, for instance. Right, let's execute it. Let's see what happens. It says match found. So we did find the element 60. And that's how a binary search works in Java. Right, guys, so another thing that I want to talk about in arrays is sorting arrays. So I want to talk about a basic sorting algorithm that you can use. There's plenty of sorting algorithms. There's in fact so many that you can probably think of when you go into programming. But for now, because we're just starting to learn about arrays, I want to talk about selection sorts in arrays, right? So selection sort, basically what it does is it sorts the elements. So we have a double list here, and we're basically passing this parameter list3, and we're calling this method selection sort. Let's see what the method does. Right, if we go to the bottom to selection sort, there we are. So basically we have this list, and what we're doing is we're basically looping from 0 to to the last index minus 1, right? So the length of our array is actually 10. The length of our array is actually 10. So we're looping from 0 to 8, right? We don't want 9. 9 is the last element, but we want element 8. So we're looping to there, and we're saying double current min. So the current min is going to be set equal to position 0. And we have to also take the current min index as well. And then we go inside, there's an inner loop, right? And this is where the magic starts to happen. So we have this loop where we're saying j is equal to I plus 1. So if our position was at position 2, then we would start at number 3 and we would go forward until the last element. But since we're at 0, we're going to start at position 1 and we're going to go upwards to the last element, which is element 9. And it says here, if current min is greater than list j, right? So list j is that position. So our current min was currently assigned to list I, but now we're saying if current min is greater than list j, the element at that position j, then we want to set our current min equal to the list j element. And our current min index will change, it'll change to j. And now after we go out of this loop, we want to say, hey, if current min index is not equal to I, so in other words, if this loop here, right, this loop that I'm highlighting hasn't changed anything at all, then we don't have to do this step. Then that means that the element that we're currently on is in its right position. But because it's not in its right position, we're going to say list current min index is equal to list I. So now we're changing it. Now we're making the list min index equal to list I, right? So the current min index is going to be, so that current min is basically the element that's actually the lowest. And that element that's the lowest is going to be sent to that position in the array. So our position was at I equal to 0. So if we go back to the top here and we look at our array, so we know that the lowest one over here is 1.0. So this 1.0 here is now going to be swapped with 4.5 over here. So both the elements are going to be swapped, right? So we're going to see that happen. Right, so that's basically what's happening. And then list I, of course, is going to be equal to current min. And this continues, right? And it keeps going. It basically, let me just show you what it looks like so you understand. So it starts here and then it checks all of these elements over here. Then it goes up one, it starts here. It checks all of these elements over here. Then it starts here, then it checks all these elements over here. And then it continues and it goes up to here, but it doesn't go to the last element. So, it doesn't go all the way to the last elements. For the first loop, right? The I loop goes up to the last element minus 1. So this would be index 9, so it'll go up to index 8. However, the J loop that we saw goes up to the very last index, but it starts at the current I position plus 1. So that's why I've been showing it like this, where one highlight, and then I've been doing it like that. Okay, guys, so let's actually see if this works, right? Okay, cool. So we have our arrays actually sorted now. So we have 1.0, 2.1, 3.4, 4.5, blah, 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 up to 9.8, 9.2, right? Okay, so that's basically how we can sort an array. Okay, guys, so another thing I want to talk about in arrays is you can actually go further than a one-dimensional array. You can actually declare a multi-dimensional array. So we have a two-dimensional array over here called tic-tac-toe, and that's basically, it's a tic-tac-toe game. And we assigned all these different X's and O's to all these positions. We've called it a character array because we only need the character X or the character O. And we basically printed it out to the console. And you notice that instead of using arrays.toString, unlike a normal array, because this is a multi-dimensional array, we must use the method deep_toString. So we have to use deep_toString, right? So if we run this, you will actually see that it prints XXO, OXX, OOX, right? Well, that's how you basically declare a two-dimensional array. Now, what about looping through a two-dimensional array? How does that work exactly? Right, so you can see I've actually I've actually put in these statements here. So now I have tic-tac-toe 2, and we've, instead of actually assigning each individual character to an element position, we now actually just declare it like this. Oh, one thing I want to mention, I forgot to mention this, but So we have this tic-tac-toe. So how does it work? We have it like this. We have row and then we have column, right? So keep that in mind. So the first index is the row and the second index is the column. So row and column, you'll see that now as we actually print out this tic-tac-toe 2, right? So if we to loop through a two-dimensional array, you go for int row equal to 0, rows less than, and then you go dot length. And then you do it for the column as well. So the column, so this represents one row, this represents one row, but all three of them represent 3 different columns. So to loop through a specific column, to loop through a specific row in a column, we have to specify tic-tac-toe 2, and we have to put in brackets, in square brackets here, row. So we're referring to row 0 is the first row we'll start with, and it will go up to row 1 and row 2. So let's actually print this and see what it looks like. You can see we have XO, so you can see X1. So the player who played as X actually won this game. He got a diagonal finish, and he won the tic-tac-toe 2 game. Right. Now you can actually take this a step further, and you can actually use a 3-dimensional array. Now let me show you how that works. Right, so we have this 3-dimensional array. It's pretty scary looking, not that scary looking, pretty nice looking actually. So we have, so basically what I've done is I've created an array and I've called it water. And what does it do? We basically have containers stacked next to each other. Each container has a certain amount of liters of water, and it's stacked in a 3-dimensional way. It's stacked 3 by 3 by 3. So it's 27 different, we have 27 different containers, or should I say 27 different bottles, and each bottle contains a certain amount of liters of water. And this is how I've declared it. So now you've got to open up the braces more. And see, you can see I've separated them by commas, and then I've separated by commas. So that's something you'll pick up on. And because this is a 3-dimensional array, the very first element is index, that is the X element. Then we have the Y element. Then we have the Z element. So X, Y, Z, right? Okay, and I've created these 4 variables. So these are the 4 variables that basically tell you the amount of liters we have inside different levels, different levels of the stack, and all together. So you can see it starts from X, and then it goes to Y, then it goes to Z, and it basically adds in all the liters together. But it says here if X2 is equal to 0, so X is at row, so basically we're talking about X2 is row 0. So the very top row, or the very top stack, is we're going to add all the elements in that stack. If it goes to the next stack, we'll add all the middle elements together, and then if it goes to the next stack, which is the bottom stack, then which is basically index 2, X2 is equal to 2, then we're going to add all the liters of water in that final stack. Right, so if we print this now, you'll see there's 37 liters in the very top stack, 52 in the middle stack, 39 in the bottom stack, and altogether we have 128 liters of water. Okay, and you can actually check, you can actually verify that this is true, because this right here, this entire row here represents one stack, right? So 2 plus 5 plus 1 plus 5 plus 3 plus 8 plus 1 plus 9 plus 3 should give you 37 liters. And you can actually verify that here as well. This should give you 52 liters and so on. Okay guys, so that's basically how you can create a 3-dimensional array in Java. Okay, so I think I've gone through everything quite thoroughly. Alright, so let me go back to the cam screen. I'll be there right now. Okay guys, so that brings us to the end of the video, the end of the lesson, should I say. So we've actually gone through arrays. We've spoken quite a lot about arrays, how we can use arrays and methods, how to declare array, how to put elements in an array, how to take out elements, how to copy elements, how to loop through an array, how to use a for each loop. So we've gone through quite a lot in this lesson today, and I'm sorry that uploading has been quite slow. I have been trying to upload. I've been consistent, but not exactly consistent in a way with like my videos. But more content is coming, and I'm going to teach you more. I also want to apologize because I did say I was going to teach you guys how to debug. I haven't done that yet. I apologize for that, but we will get to that. You can expect that very soon. But otherwise, guys, I just want to thank you all for coming along this journey with me and watching this video. It's not really a journey; it's more like a lesson. You learned a lot. Well, it is a journey for me. Yeah. So thank you so much, guys. Please subscribe to my channel if you like it. Like my videos, share the videos, comment, and follow me on my Instagram. It's called Darshan Graphs. I'll put it in the link in the description below. And I'll leave a link to the playlist of Java related videos, and I'll put the previous Java video that I did on that end screen as well, and there'll be the icon as well to subscribe. Okay, cool. So guys, thank you so much for watching, and I hope to see y'all in the next videos to come. Right. Thank you so much. All right, comrades. Sai Sita Ram.